Bismillahirrahmanirrahim. Good afternoon, everyone. Today, or actually, lecture number 5, but part 1. Here, we will talk about the electricity within the body. Actually, at first or second lecture, can't remember, who was talking about the electricity. Specifically, who was talking about the cell. In any cell in the body, it has electricity, and we told inside your cell different charge from outside, and your cell has different potential. Let me use light show. Has different potential across its membrane. We will explain all of this information again, but will be a little bit deeper. That's the content. I'll explain all of these headline. Here, the nervous system kinds. Actually, we have two kinds of nervous system. First one is the central nervous system. It's from two kinds. Actually, when we talk about the blood and the vessels, was focused on the heart. Okay. Here, when we talking about nervous system, at specifically central nervous system, we will focus on the brain and spinal cord and the other nervous cells. Here, let me start from the first statement. Like I said before, we will focus on the brain and spinal cord. It consists of brain and spinal cord, the nervous cells and the nervous cells. Here at this picture illustrates to us the blue lines here are not vessels. These are nerve fibers, nervous lines. Okay, because that I can prove that by using any kind of needle. I use any part, any point in your body, it will be hurt too. That means you have nervous cell in all your body. Like when you was talking about you have blood vessels in all your body. Because that I can prove that by using the same easy experiment, by using the same needle. When I push it in any point in your body, you will bleeding. Okay. Here, let's come back to the central nervous system. It's focused on the brain and spinal cord. First one, afferent nervous. The nerve fibers that transmit sensory information to the brain and spinal cord. This two brain and spinal cord, this kind is afferent nervous. Sorry. Second one, instead of two, you will say from. That's mean from brain or spinal cord to any part in your body, to any part you want to move it in your body. The nerve fibers that transmit information. Instead of two, you will say from the brain or spinal cord to the appropriate muscles and the glands. Here, take idea. This is the parasympathetic and sympathetic. It's just to I used it to prove something. Let me explain it. The second kind of nervous system is the autonomic nervous system. Here's two kinds, sympathetic and parasympathetic. It controls various internal organs. Internal organs. What that's mean when I say internal organs? That's mean all of these. Because that I used this picture. The heart, intestines, glands, all of these belong to the autonomic nervous system. Here, let's start to talk about when I don't move, I don't use any fingers from these. What does mean? That's mean the nerve fiber, the nerve line from my brain or spinal cord until this finger or another one, doesn't matter, it's not stimulated, or we can say polarized, not stimulated or polarized. That means any part from my hand doesn't move because I didn't give any order from my brain or spinal cord. Now we will talk about what is the polarized nerve cell or not stimulated nerve cell. It consists of central core. Here, this is the central core. This the nerve cell. All of these ball is a nervous cell. This the core, the central core. The fluid inside it consists of, inside the nerve cell, consists of a huge amount of negatively charged and organic ion and a high concentration of potassium. Here, this nerve cell consists of central core, fluid, inside this fluid a huge amount of potassium, ion potassium, that means K plus. The central core is surrounded by a membrane, this the membrane, the out of this circle. This is important. We will focus on it to explain what is the stimulated nerve cell and what is the not stimulated nervous cell. Because that, let's focus on it. The central core is surrounded by a membrane through which a small ion can pass under a certain situation. Let me say the statement again. The central core is surrounded by a membrane, this out circle, through which a small ion can pass under a certain situation. What that's mean? This membrane will act as a wall in a specific situation. At another specific situation, will act as a gate. Okay. The fluid immediately outside the core has a high concentration of sodium ions. Outside this unit cell, the nerve cell, outside this core, you have a lot of sodium at ion sodium, that's mean Na plus. Here, like I said before, we can say not stimulated or polarized. Here, when anyone from these fingers start to move, that's mean the nerve line, the nerve fiber from my brain to this finger now is stimulated. That means it's not polarized anymore. There is a potential difference. Here, like I said before in the previous lecture, first or second, I don't know, when I was talking about the nerve cell has a charge inside, it's different from its outside, and it has a different potential across this membrane. Okay, let me explain that again with some detail. With one will be positively charged outside or inside, and how much different potential this across membrane has. There is a potential difference, that's PD, across it about, it's 70 millivolts. 70 millivolts. The outside of the membrane having a potential of about 0. The outside. That means across this membrane, it's equal plus 70 millivolts. Okay? Outside this circle, it's equal 0. That means this nerve cell is polarized, not stimulated. Outside equals 0. Focus on that. And the potential inside, which called membrane potential, equal minus 70. That's mean inside minus 70, at the membrane plus 70, the total outside equals 0. That's mean again this units, this cell, this nervous cell is polarized. By that, calcium, a lot of calcium, a lot of potassium, sorry, ions, that's mean plus, a lot of negatively charged inside this fluid, outside the central core. Here we have the membrane, it's thick. Here it acts like such as a wall. The different potential across the membrane equal 70, inside equal minus 70, the result outside equals 0, and we have a lot of sodium ion outside. Now let's start to talk about the stimulated nerve cell. When this finger start to move, that's mean the cells from my brain to this point, to this finger, is started to be stimulated. That means not polarized anymore. When the nerve cell is stimulated, there are 3 operations need to be occurring. We have 3 steps. The nerve cell will pass from it to can be stimulated, to can be changed from not stimulated, from polarized to stimulated, and to come back polarized again. That means its job is done to send this signal from point to point. Let's go deeply. The first step from these 3 is depolarization. That means at first it was polarization, now started to take signal from my brain to this finger, or reverse from my finger to my brain, doesn't matter, the same situation. Will change from polarized to depolarized to be the first step to can send signal from point to point. Depolarization is the first one. The membrane suddenly become permeable. What does mean permeable? Will acts like a gate. Will let pass something through to sodium ion, and they are able to move into the axon, the central core, as a result of both diffusion and the influence of the negative charge inside it. What that's mean? We know in the magnetic and in the charge chapter in your high school, you studied that the dislike charge attracting each other. That means the attracting force, it was here, but the wall, this membrane, was act as a wall to prevent this attraction force between these negative, different or dislike charge. I mean the negatively charged inside the nerve cell and the sodium ion from outside. That means the membrane will be like a gate to let the sodium ion from pass from outside to inside. This increases the positive charge inside the axon. Sure, because here inside the nerve cell, it has more than past uh, positively charged ratio is increased inside it because it has now a lot of sodium ion from outside and increases the membrane potential from minus 70 millivolt to be equal 0. It's the first step. By that, the last result is the different potential inside the nerve cell now equals 0, is increased from minus 70 to be 0. Reverse polarization. The membrane potential inside increased at the next step without go deeply. Here, the different potential is increased as the reverse polarization from 0 to plus 30. It's the main goal to this nerve cell to change its inside from minus 70 to be plus 30. Then the membrane immediately becomes impermeable. That means the membrane will change from gate to act as a wall again. What that means? The ion, the sodium ion will stay inside, will stick inside, or will go out again? No, will stick inside the nerve cell and so traps them inside the axon. Here, the last step after this nerve cell did its job. The inside different potential increased from minus 70 to 30 from repolarization and reverse. It was the next step. Now we'll come back to be polarized again. The last step is repolarization. The potassium ion continue to diffuse out and quickly restore the positive potential outside the membrane, which take only about 2 milliseconds. What does that mean? That means some vacancies, some holes will be outside this membrane before reach the repolarization. And the sodium ion is sticked inside the nerve cell before the wall act to be a wall again, this membrane, before act a wall again, some potassium ion will diffuse out, will take these vacancies, will take the sodium vacancies, okay? By that, this known as an action potential. This process will take approximately 2 milliseconds to each cell. Here, this curve is straight to us when the membrane, when the nerve cell was what? Was polarized. Its inside equal different potential, sure, equal minus 70 millivolt. At some time less than 1 millisecond, here is the membrane potential with millivolt, here time with millisecond, less than millisecond. After that, increased to B0. That's mean it's the tape number 2, the reverse polarization, sorry, the depolarization here from minus 70 to B0. After that, we work to on reverse polarization here from minus 70 to 0. After that, from 0 to 30 plus 30, that's mean reverse polarization. After that, start to, after did its job, we'll try again to first situation. This first situation was polarization, or come back to be polarized again by decrease to be approximately minus 70 again. All this process take approximately 2 milliseconds. Okay, here repolarization. Here the first one was depolarization. After that, reverse. Last one was repolarization. Here, the signal inside the nerve fiber, nerve line from my brain to finger, or from finger to my brain, will the signal will pass from the nerve cells by using this way, by using the situation from one to one. If you remember that when I was talking about the programming language, we say it's equal 1-0. And after that, I give this like an example. And after that, explain to you how the cell send and take the order from the brain or spinal cord, doesn't matter. It was positively, negatively charged. Here, this picture proves my words. Here the signal inside this nerve cell. Here it's not polarized nerve cell, but the second one is polarized. The third one is polarized. Here, when it's not polarized, it has a signal inside it. And when send the signal to the next nerve cell, that's mean it acts like that, will be negatively outside, positively charged inside, and it's not polarized again. When that's mean here, its job is done, and we'll try, this nerve cell will try to send the signal to another neighbor signal. By that, will be will be polarized again, and the second one will be polarized, and keep going until reach the specific point. Here, this device is interesting device, is very important device. It used to send some different potential to some part from your body to can test it. Let's take some information about it. Electromyography. E from electro, M from my, G from graphy. Electromyography is a diagnostic procedure to assess the health of muscles and the nerve cells that control them. EMG results can reveal nerve muscles dysfunction, or let's say defect, or problems with nerve to muscle signal transmission. We can use it to test some parts to know the problem, the defect from this part or from this nervous line, okay, this nervous way. Where is the problem? From sending the signal or from taking the signal from this specific part? How it works? Motor nerves transmit electrical signal, that's mean different potential, that causes muscles to contract, that's mean different potential. AMG uses teeny devices called electrodes to translate these signals into graphs, from signals to curves, to can the specific, to can the doctor, the nurse, whatever, to read the result. Specialists, yes, specialists. Sounds or numerical values that are then interpreted by a specialist. During a needle, this needle not to send any liquid, any medical liquid, no, it's an electrode. One of these two electrodes belong to this device, and it's inserted directly into muscle, records the electrical activity in the muscles. Another part of it is the electrode stickers, this part. It's not bleeding process, it's not infection sender. These two things make it unique. It's are a good advantage. Measure the speed and strength of signals traveling between two or more points. By that, it's not risk